In lesson 2.4, we're still looking at polynomials and roots, but here we're looking for imaginary roots and complex zeros. Whenever we see a negative under a square root, we usually say we can't do that square root, but actually we can. So what we do is we'll factor out the negative and it becomes an I, and then we just simplify the rest of the root. So here I've got a negative 2 in the radical. I can actually take that negative out, and then I get I radical 2. Here, take the negative out, you get I, and then we've got square root of 9, which breaks down into 3 times 3, which you take out your pair of 3's and you get 3I. This one, the negative comes out, and then we're going to break down radical 24. So 2 goes into 24, 2 times 12, 2 times 6, and then 2 times 3. And you're looking for pairs of 2 because it's a square root. You've got one pair of 2's, so that will come out of the radical with the I. And then you have a 2 and a 3, which don't make a pair, so you multiply them back together and you get 2I radical 6. Here the negative comes out, and we're going to break down 48. If I take out 2, that will give me 24. Take out 2, and that's going to give me 12. 2 times 6, 2 times 3. And I've got a pair of 2's and a pair of 2's and a leftover 3. So each 2 comes out, which makes 4I, and then you're left with a 3. So 4I rad 3 for radical negative 48. So when we see an I, it looks like variables. So when you multiply imaginary numbers, you treat them like variables. It's also important to remember that I comes from the fact that there's a negative in the square root. In fact, a negative 1. So the square root of negative 1 will give you I radical 1, which is just 1I. So if I were to square both of these, square both sides of this little equation, I end up getting the fact that I squared equals negative 1. So anytime we have a I squared, we can change it into a real negative 1. So let's look at this multiplication here. We have negative 3I times 7I. That's going to make negative 21I squared. And we just said anytime you have an I squared, it becomes a negative 1. So you have negative 21 times negative 1, which is positive 21. Here, when you multiply, you get negative 10I squared. The I squared becomes a negative 1. And so you plug in negative 1 for your I squared, and you get 10. And here I've got foiling. So we're going to FOIL these. If I do first, I get 12. And then outside, I get negative 9I squared, or just negative 9I. And then I've got inside 8I. And then last, negative 6I squared. And then if you collect like terms, I get 12. Those make negative 1I. And then this I squared is going to change to negative 1, which makes this a positive 6. So the 6 and the 12 go together to make 18. So you have 18 minus 1I, or 18 minus I. Here we've got 2 times 2, 2 times negative I times 2, and then I times negative I, which would be negative I squared. Your i's cancel out, and then this I squared is negative 1. So you have a 4 minus a negative 1, which ends up being 4 plus 1 with your double negative, so you get 5. Every time you have a complex number, you also have another complex number called the conjugate. The conjugate of a complex number would be written like this. If it's a plus bi, then a minus bi would be its conjugate. So let's look at complex numbers and pick out what's real and what's imaginary about it. So the real part of this number is negative 6, and the imaginary part of this number is the 2i, and the conjugate always just does opposite of the imaginary part. So the conjugate would be negative 6, then minus 2i. Here, there is no real part of the number, it's 0. The imaginary part is the negative 4i, So remember, conjugate is opposite of the imaginary part. So it would be 0 plus 4i, or positive 4i. The real part of 10 is 10. The imaginary part is 0, so the conjugate of 10 will still be 10, because we're not changing the imaginary part. The real part of 5 is 5. The imaginary is the negative 2i, and so the conjugate would be 5 plus 2i. The real part is negative 7. The imaginary part is 3i, and so the conjugate would be negative 3i minus 7. We know that the degree of a polynomial tells us how many zeros the polynomial has, but not all those zeros have to be real. So anytime you have a complex zero or imaginary zero, they always come in pairs, so you're also going to have its conjugate. So if 1 plus 2i is a 0, so will 1 minus 2i. If negative 3 is a 0, so will 3i. If negative 10 plus 5i is a 0, so is negative 10 minus 5i. And if 3 is a 0, then that doesn't give you any extra zeros. 3 just tells you 3. So in the next example, they're going to give you zeros and ask you to write the polynomial. And so we're kind of doing this backwards process that we've done before. It's backwards of factoring. So here we have the factors and we want to FOIL them or multiply them back together. So when I look at what they give me 3 zeros and they say it's going to be degree 4. So I know at the end it's going to be x to the 4th. So that's just kind of my clue to see if I do it right. So when they say x equals 5, I'll say x equals 5, and then x equals 2, x equals negative I, and if negative I is a root, so is positive I, the conjugate. And so what we would do is turn these into factors by setting them equal to 0. So to get this to equal 0, I subtract 5 to the other side, and now it equals 0. Subtract 2 to the other side, and now that equals 0. Add I to the other side, and it equals 0. And then subtract I to the other side, and that equals 0. So now we've got 4 factors that we can multiply back together to create the polynomial. You can only multiply 2 at a time. So if I multiply these two together, I get x times x, which is x squared, x times negative 2, and I have x times negative 5, so that's going to make negative 7x. And then I have negative 5 times negative 2, which is positive 10. So those make that. Here I've got a difference of 2 squares. So when I multiply x times x, I get x squared. X times I is negative I, and then x times negative I is negative I, and x times I is, let me just show you. So I've got x times negative I, and then x times positive I. And then I've got negative I times I. And these middle terms cancel, is what I was going to say, but was stumbling. So I've got x squared minus I squared, and then I squared becomes negative 1. So this is going to be x squared plus 1. So now I've got it down to these two things, and I'm going to multiply those. And so we're going to rewrite that over here. We're going to FOIL those together, and that will be our final answer. So if I distribute x squared, I get x to the 4th, negative 7x cubed, and positive 10x squared. Distribute your 1, and you get 1x squared, negative 7x, and 10. And then you just collect like terms. So I've got x to the 4th, I've got a negative 7x cubed, and I've got 11x squared. And then I've got a negative 7x and a 10. So that is my polynomial with those given zeros, and it is degree 4. So I've got what they said I was going to get. For B, we're going to do the same thing, only if this is not a 4 comma negative I, it's a 4 minus I. So I've got 4 minus I, which means I've got another answer of 4 plus I, the conjugate of that. Now this one's a little weird because you've got multiple things going on. What you want to do is bring these to the other side. So first I'm going to subtract 4 to the other side. And then I'm going to add the I to the other side. And now I've got it to equal 0. And what I like to do is group the real part together, or the x minus 4 together, and leave the I off alone. And so what I'm going to get here then, if I do the same thing, is going to be x minus 4, but it's going to be minus I. And so these are the things that I'm going to multiply together. Now here with foiling, I like to do a box just so it looks a little more organized because I've got all these extra I's going on. So if you like box method, this is when I would use it. But if you want to distribute, you can totally just distribute here. So I put the first term across the top, and I leave x minus 4 together. And then I've got x minus 4 minus I down the side. And then we multiply them just like a Punnett square in biology. So I've got x minus 4 times x minus 4, which would be x squared minus 8x plus 16, if you FOIL them. And then I've got x minus 4 times positive I in here, x minus 4 times negative I here. So I'm going to put a negative in front instead of right here, negative I. And then I've got I times negative I, which would be negative I squared. So what you see is these boxes cancel, and that's always going to happen with your conjugate, is the I terms are going to cancel. And then in here, I end up getting a negative, negative 1, and so this is really a plus 1, this box. And so what I end up getting is this thing plus 1, which would be x squared minus 8x plus 17. Okay, so let's try another one. I have x equals negative 2, which gives me x plus 2 when I set it equal to 0. I have x equals negative 3 plus 4i, which is going to give me x plus 3 minus 4i when you set it equal to 0. And then I would also have x equals negative 3 minus 4i, the conjugate of that. And so that's going to give me x plus 3 plus 4i when I set it equal to 0. And I recommend always putting the i's together first. So I'm going to combine these two together in the box first. And I'm going to put x plus 3 minus 4i on top, and x plus 3 plus 4i down the side, and then we multiply them together. So x plus 3 times x plus 3, I'm going to get x squared plus 6x plus 9 when you FOIL these two together. Then I'm going to have negative 4i times x plus 3 and positive 4i times x plus 3. And then you multiply your i's together and we get negative 16i squared. Again, these terms are opposite. They cancel each other out. And then this I squared is a negative 1, so this box becomes positive or plus 16. And you add the plus 16 to that box up there. And you end up getting x squared plus 6x plus 25. And so that's what we have right now. Remember, it's supposed to be degree 3, and we still have this x plus 2 to take care of. So now we multiply this by x plus 2. So if you distribute your x, you end up getting x cubed, 6x squared, and 25x. Distribute your 2, and you get 2x squared, 12x, and 50. And then just combine like terms. So you have x cubed, and the x squareds will make 8x squared, and the x's are going to make 37x, and then you've got a 50. And here it is degree 3, which is what they said you were going to get.